Hi, this is Corey with Gravwell, and this video is a threat hunting exercise presentation that was originally presented at Security Weekly Unlocked, but we thought we wanted to make it on demand and available because it does a really great job showing off some of the new features in 4.1 Gamma Burst with compound queries and building statistical models, cutting out the noise floor to see weak signals within a bunch of different data, and also kind of illustrates what it looks like when you're hunting through endpoint and network data all together. So hope you enjoy, and we'll catch you next time. So in this example, we've got a lab environment here. And in this environment, let's just take a look at what the malicious activity was. So opposite to a murder mystery, I'm just going to tell you who done it right away. And how it worked is a user was phished. They downloaded this totally not malware.exe from a website promoting cute puppies, and then executed that malware. And when the malware is executed, the malware does a port scan of local subnets. It exfiltrates that data over DNS, and then it copies itself to any file shares that are addressable by the system, and renames the copy to a list of enticing file names like holiday bonuses .pdf and things like that other people might click on. And then in this environment, we had another user on a different machine execute that malware by clicking on the holiday bonuses.pdf.exe and thus propagating through the network. And so now let's just take a look at the actual events that are generated by this type of malicious activity. And in order to do that, we're going to start with a different tip. So as a consequence to this being a custom malware, there's no strong signals that are going to be available because this malware is not going to be known. That you can't look up the hash in any threat database. If you upload it to VirusTotal, you're not going to get anything because this is custom malware that is not using any kind of toolkit that's used by an APT. It's not using any code snippets or anything from anywhere. This is something that we created. Which should illustrate that relying exclusively on some of these detectors is going to leave giant gaps in your visibility when it comes to any sort of novel technique or novel tool. And so we're going to start with some anomalous behavior with the fusion of weak signals. And in order to do that, let's switch over to our Gravwell interface here. And so if we wanted to, let's just take and do a basic search. So within Gravwell, again, our whole thing is let's take logs and let's take them in the system and do stuff with them. We do, of course, have things like dashboards. So one of the data sources that's in this environment is Zeek, which is a fantastic data source with lots of great things. And so we have, our dashboards here that we have available. Of course, we've got Zeek DNS information, Zeek connection overview. We can do things here where we're clicking around, we're looking, we're observing what kind of things are available in order to make use of the Zeek data. But anybody's got dashboards. Let's go through and actually do the threat hunt and look into investigating this malicious activity because that's where sort of things get fun and where the strength of the platform really shows itself. So if I run this search, I'm not going to get into what each of the searches do. It's probably worth pointing out, though, that on our dashboards, all of the dashboard activity is driven by searches at their core. So any of these tiles have a search related to it, and the raw data is present at the Gravwell indexer. And so you can always get to the root cause analysis. There's no normalization. You're looking with the data. That's the part that makes it more of a commoditized data science and less of a let's turn and depend on these types of normalization and taxonomy here. And so if we just do this, just a basic graph that shows us network activity, but as is a problem with weak signals, it's a little noisy. So one of the things that we can do, especially as a new feature with the upcoming Gravwell, we have compound queries. Basically what this allows us to do is run some data science over the time frame and establish a baseline per host. So we're dynamically creating a baseline of activity on the host level right within this search, and then referencing that baseline later. So this search goes through and buckets up this data and cleans up that chart a little bit. And then what we're going to do is I'm just going to uncomment this piece right here. And what this is going to do is drop the noise floor. And we're going to say we only want to see network activity that's 2 standard deviations away from normal. As that's dynamically generated. So we're not relying on some third party's definition of normal. We're relying on our actual environment's definition of normal, which is really important. So that's the part that makes this tailored to your organization. This is the whole context is key, because the context is generated by your data, which is crucial. So we've seen here, when we remove the noise floor, we've got one host that kind of stands out here. 10.0.1.6 has been talking to more people than he usually talks to, which is not an alert in and of itself. If you did this in a real network, you're going to be busy dealing with this. It's a weak signal. But the interesting thing about weak signals is they can be fused with other weak signals to try and figure out what's going on. And so one of the other data sources that we've got available is Sysmon. And if you're not familiar with Sysmon, it's a utility from Microsoft. Basically, it's logging every process that's ever created, every registry key that's edited, DNS requests by the individual host. This is an endpoint system. It's basically akin to like a Carbon Black or something like that. We're collecting data off of the endpoint. And then Gravwell takes those Windows events out, and we've got them in our environment here. And so one of the things that you can do also as a weak signal is process whitelisting. A little more useful in OT than in general IT, but as a weak signal, it can be used. And so what I'm doing over here in this tab is I'm just searching for the previous 4 days, and I'm going to create this baseline. So again, just like we did previously with that search to identify what we're looking at, this also creates a baseline. So on a per host basis, which processes have been seen in the last 4 days? And then we're going to save that within Gravwell as a resource that we can use. Because if I come back over here, I will grab this search and reference that baseline to collect more weak signals. What processes have we not seen before in the previous 4 days? And we get a short list in this environment. In a larger environment, this list is going to be much longer. And also, everything that I'm doing right now, I'm kind of manually walking through these queries. Ideally, you would, a threat hunter is going to want to automate some of this sort of more menial parts to threat hunting and focus on when we get a human involved when the context matters. But these weak signals we're grabbing, and ideally we'd fuse them together automatically to identify hosts that are similar. But just as a human here, as we're walking through this to kind of be more illustrative, I can see that 10.0.1.6 address that is present within this list as well. So we've got weak signals that are showing us the same IP address. So let's just go ahead and take a look at that. And ignoring the obvious totally not malware.exe, because this could be any name. We will take a look at this. And I'm just going to use this to get into our process create, let's see, I want to pull up, let's pull up a different dashboard here. Let's pull up the Zeek or an IP address investigator. Let's do that. And so we can pull up this investigator dashboard, which will run all these searches automatically for me, and so that I can look at them. And so we would hopefully automatically identify that this host has a problem, and we would be interested in looking at it. So we pull up this investigative dashboard, and we can see the event ID, frequencies, which users are active on the system, and do these different things. But as a threat hunter, one thing that immediately stands out is we've got some high entropy DNS requests to this host, which is interesting. Also ignoring that it is evil.gravwell.io, which sounds not very nice, because it could be any innocuous host. Just the fact that there's entropy here and there's a clear pattern. I'm at least interested in saying, what is it that this system is actually doing here with these DNS requests. And so our combined weak signals now become sort of a strong signal. And that gets us to sort of the next phase where we're going to look at it. Let's create a hypothesis. So an example of a bad hypothesis is this 10.0.1.6 is funny looking. Just like in Fargo, funny looking how, you got to be a little more specific. And so we can state, so we've already got a time where we initially were seeing that increased network activity. And so we say around 12.1 at 2208. The IP address 10.0.1.6 had some unusual network activity correlated with the execution of a never before seen process. So our hypothesis is that totally not malware.exe is in fact a liar, and it is malware, and that matters. And so now that we've got our hypothesis, that's when we can get into conducting the next points of our investigation. So I'll switch back over to the live system. And we see this. So one of the great parts about having multiple data sources is we can take a look at Zeek data for this domain. So let's just grab the evil and pull it up in Zeek. And surprisingly, there's nothing here. If I go back and try one of the actual records, let me just launch this. Okay, sorry. So we'll cut that. If I go back and choose the Gravwell.io and look at this in general, like Zeek has seen this, but it does not see the records from that we're investigating. And this is the part where I'm going to step out of the demo and say I actually don't know why this is. I have ran this environment multiple times. I tear it down, I stand it up, and 9 times out of 10, those records show up in Zeek. I don't actually know, as a person, why they didn't show up in Zeek this time. But I left it in because I think that's interesting. It illustrates a point. It's very important to have multiple data sources for the same sort of desired activity. So we're talking about DNS activity here, and having Sysmon to give us DNS and Zeek to give us DNS, plus maybe the logs from a server, is very important because we will want to correlate those. It helps us to refine our visibility. It helps us to know if we're looking at the right thing. And so having more data together is what's going to be important. And so, okay, we know that there's this activity going on. We know that there's potentially this malicious domain. Let's go ahead and switch to manual control. So up until this point, we could have automated all of this business. But at this point, we want to get a human involved because threat hunting, like finding ODAs, is as much art as science. And so that's where we're switching to. Let's switch to manual mode and get at this activity. And so this is the final piece in this demo. Really, the point is to see this activity and do a little bit of hunting. And also, really, we're just going to highlight structure on read benefit. So I have this query that extracts out the different pieces to the domain. So this is the DNS request. It's 3 pieces separated by a period. And as a threat hunter, if I'm looking at this, I'm going to kind of reverse engineer this a little bit, and I'm going to be like, okay, this is something's going on here. They're sending something up. And I look at this data and I'm like, this looks like it has a pattern. Is this maybe some base 64? The nice thing about being structure on read is we can add things in the pipeline to do additional data science-y style analytics, statistical analytics. This is also exactly how we turn on and activate and use machine learning as modules within this analysis pipeline. So I added a base 64. That didn't actually do anything, but maybe it's not base 64. Maybe it's just hex ASCII. And in fact, when I add in the decoder for ASCII, I've now turned that goo into text. And it looks like this malware is making these DNS beacon requests and encoding IP address port information about our network up to this DNS server to make these requests in. And so now we're assembling a little bit more information about how this malware behaves. Now we've identified that, okay, this is definitely reporting up reconnaissance information to this third-party site, which is what we would want to investigate. So what if we wanted to create a rule about this? And that's where we can sort of do more interesting things. So we say, okay, what if we search for this hash? So this is the hash of the exe. We get this from Sysmon, we had identified earlier. If we search for this hash, let's find any file name that has ever been present with that hash on any of our endpoints. And then we may be interested in using Zeek to identify that. So we're going to create a resource where we're basically saying, here's the list of files that are bad, and we'll create a rule sort of around that. And then if I wanted to use that rule, we would run a search like this one, which is referencing our APT fancy lumberjack, to look within Zeek data and find any reference to that, to those file names. And so now we can take what we learned from our Sysmon data and combine that with our Zeek data to get a more thorough tabs on what this malware is doing, where it is, where it's going. We see it's being used in Samba here. Maybe we can pivot to, instead of Zeek files, we'll use the Zeek SMB log format, and then we get the full path on where it is, what the activity was, SMB file opens, SMB file renames. We can see how Totally Not Malware EXE was renamed to holidaybonuses.pdf.exe, and it just this is where the capability of being able to rapidly pivot through logs, rapidly explore, change the pipeline to dynamically analyze stuff. This is where the structure on read, threat hunting side of things really shines, because all of this is out of the box. You're not going to have an out of the box solution that does this, rather, because none of this, has been seen before. It's unique to the environment. It's unique to this malware, and so that's where people need to be able to gain vision, is of these types of things. And so if we take a look at the summary results so far, we saw that we identified malicious binary belonging to a new APT, which we're going to name Fancy Lumberjack. We've associated with the scanning activity, MITRE technique, associated it with malicious domain MITRE attack technique, and associated with SMB lateral movement. So we're going to set these things up and create these rules for detection. And then those rules become part of our process. And within Gravwell, we have what we call kits, which are sort of pre-built things, but organizations can have custom kits, which basically become detection as code, because they can be versioned in a Git repository and utilized in that way. That's kind of sort of the new forward way that things are going. We want to be process oriented with our detection efforts, just as we are with our DevOps, with our IT operations.